Hello students, welcome to Educate. We are going to start with the numericals of chapter Wave of class 11th physics. So let's enjoy the questions. So question number 1. Here question says a string of mass 2.5 kg is under a tension of 200 Newton. The length of the stretched string is 20 meter. If the transverse jerk is struck at one end of the string, how long does the disturbance take to reach the other end? So here, first of all, we have to find out the speed, and then we will apply the formula time equal to distance upon speed. So let's solve it. So here information given is mass is equal to 2.5 kg. Length is given as 20 meter and tension is given as 200 Newton. Right. Now, if you remember the formula, it is V equal to root of T upon mu, where mu is mass per unit length. So mu is 2.5 divided by 20. Right. Now putting these values, so V equals root of T, T means 200, divided by mu, 2.5 divided by 20. So let's write 20 here, and then we can remove this decimal from here. We make one more 0, and then 25 8 times. So this becomes root of 1600. Correct? So its square root will be 40 meter per second. So we have got the value of velocity. Now we need time. So time equal to distance upon speed. Right. So distance is 20 meter and the speed is 40 meter per second. So this will give 0.5 second. Now, this question is clear. Let's see second question. Second question says, a stone dropped from the top of a tower of height 200 meter splashes into the water of a pond near the base of the tower. When is the splash heard at the top, given that the speed of sound in air is 340 meter per second? So what is the case? Stone will fall from here. It will fall from here, and then sound will be produced, and then sound will travel to the same height. So here in this case, time taken, say it is t1, it will be h divided by speed of sound, and here say this is t2. So here we will apply the formula of free fall, that is h equal to half gt square. So we need two times, we need t1 and t2, and then we will write their sum. So first of all, let's calculate the time taken by stone to touch the water, and after that we will calculate the time taken by sound to reach the observer. Right. So for this purpose we evaluate t1. So from here h is given as 300. So 300 equal to half g. In our question it is given 9.8 into t square. So 600 divided by 9.8 under root will give, say it is T2, right, as we have observed. Now we can evaluate. So on evaluation, we will get 7.82 seconds. 7.82 seconds. So we have got the time that a student takes to reach the water level. Now, again, we have to find out the time that sound takes to travel the same distance. So T1, say, so T1 will be equal to how much? It will be equal to 300 divided by speed of sound, and that is given as 340. We can evaluate. It will be equal to 0.88 second. So total time T equal to T1 plus T2. We can put the values. So T1 is 7.82 plus 0.88 second. So this is the answer. I think you have understood fully. Question is simple. Now let's see next question. Next question says, a steel wire has a length of 12 meter and a mass of 2.1 kg. What should be the tension in the wire so that speed of the transverse wave on the wire equals the speed of sound in dry air at 20 degrees centigrade, that is 343 meter per second. So we have already studied the formula. Formula says V equal to root T upon mu, right? And here value of mu is equal to 2.1 divided by 12, right? So this is value of mu, and we have to find out tension. So let's write it as V square equal to T upon mu, from where we get T equal to V square times mu. V square means speed of sound, that is given 343 whole square into mu is 2.1 divided by 12. Now what all is left? 343 into 343 into 21 divided by 120. We can simplify it. So it will come out to be 2.06 into 10 power 4. 2.06 into 10 to the power 4 Newton, right? So question is simple. Now use the formula V equal to gamma P divided by rho. V equal to root of gamma P divided by rho. Here we have to show that it is independent of pressure. So we can consider this ratio P upon rho, and we will see whether there is effect on speed of it or not. So PV equal to constant, right, and mass upon volume is equal to density, right? So density can be replaced by, either we can replace V here, so we get the value of V here. V is volume will be M upon rho. So if we write here P into M upon rho equal to constant, so we can say P upon rho is constant. Hence, we can say that velocity is independent of pressure. Now, second portion, increase with the temperature. So again, we can consider V equal to root gamma P divided by rho. Now we are going to write here, we are going to replace P in terms of temperature. So let's see how. So rho equal to mass upon volume, or volume equal to, here volume will sit here, mass upon rho, right? But PV equal to RT, we write this value here. So P M upon rho equal to RT, right? In our question we are given P upon rho. So P upon rho will give RT upon M. So we write this value here. So this will become gamma times P upon rho is RT upon M. Gamma is constant, R is constant, M is constant. So we can say V is directly proportional to square root of temperature. When temperature increases, V will increase. Next point is increase with the humidity. So here what happens to density? So when there is humidity, so density will decrease. If density decreases, then obviously velocity will increase. Correct? Now let's see next point. Here there are certain questions, certain equations. The condition is that to represent a traveling wave, it should be either in the form of x minus vt or x plus vt or their combinations. So out of these choices, we have to find out which one will represent possibly a traveling wave. So here in first case it's not possible, in second case also it not possible, in third case there is possibility. Now we are going to see question number 6. A bat emits ultrasonic sound of frequency 1000 kilohertz in air. If sound meets a water surface, what is the wavelength of reflected sound? The transmitted sound, speed of sound in air is 340 meter per second and in water is 1486 meter per second. So frequency does not change, whether it is reflected sound or transmitted sound. Other things we can find. So here only one thing we can do. Here wavelength is to be found. So wavelength, if you remember the formula, V equal to nu lambda, right? So lambda can be written as velocity divided by nu. So two values are given and corresponding values we can find. So we need lambda 1. Lambda 1 velocity, when we consider 340 divided by frequency is 1000 kilohertz, 1000 into 10 to the power 3 hertz. So this will come out to be 340 into 10 to the power 336 minus 6. So we can write it further, 3.4 into 10 to the power minus 4 meter. This is first case when we take 340 meter per second. And when we consider 1486 meter per second, then let's write it as lambda 2. Lambda 2 will be equal to 1486 divided by 1000 multiplied by 10 to the power 3, which comes out to be 1 here. Either we can convert it in this one, 1.486, and then this can be written as 10 power minus 3 meter. Now we are going to consider next question. Next question says a hospital uses an ultrasonic scanner to locate tumors in a tissue. What is the wavelength of sound in tissue in which the speed of sound is 1.7 kilometer per second? The operating frequency of the scanner is 4.2 million hertz. So question is simple. Again, we have to find out wavelength. So V equal to nu lambda. We need lambda. So lambda equal to V divided by nu. Now we can put the values. So velocity 1.7 kilometer per second. So lambda equal to 1.7 into 10 to the power 3 meter per second, and corresponding frequency is given as 4.2 into 10 to the power 6. Now we can simplify. So 17 divided by 42 into 10 to the power minus 3. We can further simplify. So it will become 4.047 into 10 to the power minus 4 meter. Correct? So question is simple. Let's see question number 8. What does it say? It says a transverse harmonic wave on a string is described by y as a function of time and distance 3 sine 3060 plus 0.018x plus pi by 4, where x and y are in centimeter, t is in second. The positive direction of x is from left to right. Is this a traveling wave or a stationary wave? If it is traveling wave, what are the speed and direction of its propagation? Then what are its amplitude and frequency? What is the initial phase at the origin? What is the least distance between two successive crests in the wave? Least distance means wavelength. So here, what do you observe? Of course, it is a traveling wave. So if it is a traveling wave, in that case we can evaluate. So from equation, here various factors can be determined. Y equal to 3. Here units y is in centimeter. So 3, this will become cm. 3 cm sine then 36 t plus 0.018 x plus pi by 4. So various factors we can determine by writing formula like a sine omega t plus kx plus phi or phi 0. So we can easily determine everything. So here, what do we do? If we compare omega, first let's write A. A is amplitude, which is 3 centimeter in terms of meter if you want to write. So 0.03 meter. Then omega. Omega means 2 pi by t, which is omega, and that is equal to 36. So we can find t from here, time period. So time period will be equal to 2 pi by 36 or pi by 18 second. Suppose we want to find out frequency, 1 upon time period. So it will be 18 upon pi hertz. Correct. Now, initial phase is pi by 4. Now our next concern is to get here lambda. So this is kx. Value of k is given as 0.018. So let's write it afresh. So here 2 pi by lambda equal to 0.018, right? And then we can evaluate lambda. Lambda will be equal to 2 pi divided by 0.018, and it will be in centimeter. We can convert it into meter also. So then we try to find out velocity. So velocity, how will you find velocity? What is formula? If you remember, omega is equal to 2 pi by t, and k is equal to 2 pi by lambda. If we divide, like if we write omega upon k, so what will be left? It will become lambda upon t, and that is velocity. So just we have to put the ratios of omega and k. So omega in our question is this much, omega t. So omega is 36, and divided by k is 0.018. So we can get the value of velocity, that will be 20 meter per second. So this will come out to be 20. And one more thing we need, I think, wavelength we have already evaluated, and then the same thing is what is the least distance between two successive crests, that is the wavelength. So we have got all points. Now we are going to see next question. Next question says here, in question number 9, we have to plot a graph, so that you can do. We are going to discuss question number 10. For the traveling harmonic wave y as a function of x and t, 2 cos 2 pi 10t minus 0.0080x plus 0.35, where x and y are in centimeter and t is in second. Calculate the phase difference between oscillatory motion of 2 points separated by a distance of. So here we have to find out the phase difference, right? So for finding phase difference, we have to apply the formula, that is delta phi, which is phase difference, equal to 2 pi by lambda into delta x, where delta x is path difference. So this is basic relation that we are going to make use, but before that we must have the values of lambda, etc. So here let's see what is lambda. So this is omega t, this is kx. From kx, k equal to 0.008, and k is 2 pi by lambda. So 2 pi by lambda is 0.008, or lambda equal to 2 pi divided by 0.008, or 2 pi multiplied by 1000 divided by 8, which can be further simplified, 8 125, so that is 250 pi, right? So we have got the value of k, sorry, not k but lambda, correct? And now what is our concern? Our concern is to get phase difference. So as I told you, phase difference delta phi is equal to 2 pi by lambda times delta x. and 2 pi by lambda is k itself, so no need to evaluate lambda unless it is asked. So just write this value over here, 0.008. This is 2 pi by lambda because this is k, right? And then x. So here delta x. Now we are going to put the value of delta x. Delta x is given like 4 meter, then 0.5 meter, then lambda by 2, then 3 lambda by 2. So we can evaluate them one by one. So when delta x is equal to say 4, so delta phi will be 0.008 multiplied by 4, correct? And that will be in radian. Similarly, we can take delta x as 0.5, then delta phi will be 0.008 multiplied by 0.5. Then third case is lambda by 2. So when delta x is lambda by 2, then delta phi will be 0.008 into lambda by 2, and the value of lambda we can determine because 2 pi by lambda is 0.008, right? And or you can also write here 2 pi by lambda, then lambda will cancel out and you will get the answer. Similarly, next part is when delta x is given as 3 lambda by 4, then delta phi you can write, delta phi is 2 pi by lambda times 3 lambda by 4, 3 lambda by 4. So here lambda will cancel out and 2 2s are, so 3 pi divided by 2, correct? So you have got all answers. Now we are going to see next question, question number 11. What does it say? It says the transverse displacement of a string clamped at its both ends is given by y as a function of time and distance 0.06 sine 2 pi by 3x cos 120 pi t, where x and y are in meter and t is in second. The length of the string is given 1.5 meter and its mass is 3 into 10 power minus 2 kg. You have to answer following. Number 1, does the function represent a traveling wave or a stationary wave? Interpret the wave as a superposition of two waves traveling in opposite direction. What is the wavelength, frequency and speed of each wave? Correct. So obviously this will be a standing wave. So here in this question 3 parts are there, one more part is there. Determine the tension in the string. So we will apply the formula for speed to get the tension, but before that let's try its different parts so we can evaluate. So y equal to y1 plus y2. So two waves are combining here. So if we take one waves as y1 as a sine 2 pi by lambda and then vt minus x, and another say y2 equal to minus a sine 2 pi by lambda and vt plus x, right? Now if we combine the two, then what happens? Here condition is there, if you read it, clamped at both ends, that is why negative sign is taken. I have already explained you about the concept. Now from given equation, if we find the addition of the two, we will get the same result. So we can write the value of y. Here some information is given. This is resultant, so resultant is doubled. So just we have to write its value. So let's see what are the different values. So sine, this is kx, and this is cos omega t, right? So from here we can determine the values. So let's write. So 2 pi, this is omega t, this is sine, this is cos omega t sine kx, cos omega t sine kx, right? So value of k is k equal to 2 pi by, sorry, and omega is 120 pi, right? And k is 2 pi by lambda, right? So this is 2 pi by 3. So from here we will get lambda equal to 3 meter, correct? Similarly, this is 2 pi by t equal to 2 into 2 into 60 pi. Why I have written it? So that you can easily compare. 2 pi will cancel out, and time period. So here we have to find out time period. So t will be what? So t will come out to be 1 minute. I think I made some mistakes. So let's rewrite it. So what will it become? Omega, here this is k omega t. So omega is, this is 120 pi and t, right? And this is kx. K, so k will be 2 pi by lambda equal to 2 pi by 3, which gives lambda equal to 3, and from here t will cancel out. So 2 pi by t will give 120 pi, right? So pi will cancel out, so we can get time period. So what is t? T will be 2 divided by 120, 1 by 60 second, and then we can determine frequency. So frequency will be equal to, frequency is 60 hertz. Up to here I think there is no problem. Now we can find the velocity. So velocity will be how much? V equal to nu lambda, right? So nu is 60 and lambda is 3, so it is 180 meter per second. So we have got the basic points that were required. Now one more part is there in the question, that what is tension, right? So if you observe, the last part says you have to find out the tension in the string. So in order to find tension, what do we need? We have formula velocity equal to root of t divided by mu, where mu equal to mass per unit length. So v equal to root of t into L divided by m, or we can square it. V square equal to t L divided by m, which gives t equals m v square divided by L. We can put the values are given in the back. So after putting those values, we will get t equals 648 Newton. 648 Newton. Here we need mass and length. You can see in the question, it's given. What is mass? Mass is this much, 3 into 10 power minus 2 kg, and length is 1.5 meters. So from here you can easily evaluate. Now we are going to see next question. So next question says, for the wave on a string described in previous question, do all the points on the string oscillate with the same frequency, same phase, same amplitude? Explain your answer. And then what is the amplitude of point 0.375 meter away from one end? So we have to put this value in given equation. So first thing, here frequency phase will remain same, so nothing will change. And as far as amplitude is as far as amplitude is concerned, so that depends on what? From here, if you observe, this term represents amplitude, right? 0.06 sine 2 pi by 3 into x. It means it depends on x, right? So other things will remain same except the amplitude. So amplitude can be found at any distance or at any time. So here, when x is given, we can easily determine what is the amplitude. So in this question, what do we see here? What is the amplitude of a point when 0 point, here x is given 0.375 meter away from it? So we can put the value. So let's write, so amplitude, let's write it a, and in question it is given 0.06 and then sine of 2 pi by 3 times x, and in our question x is given as 0.375. so 0.06 sine 2 pi by 3 into 0.375. Now we evaluate it. So here this we can simplify, and after simplification we can use calculator to get the answer, because this will not give direct degree value. So final answer will be 0.042, 0.042, and if units are in meter, the answer will be in meter, right? So this is answer to question number 12. Now let's consider question number 13. Given below are some functions of x and t to represent the displacement, transverse or longitudinal of an elastic wave. State which of these represent a traveling wave, a stationary wave, or none at all. The first one. So here two components are there. As we have seen, when two waves superpose and we get a stationary wave, and equation of stationary wave looks like this. So first is stationary wave, right? And what about second one? Y equal to twice of x minus vt. So and what about this? Yes, it is not because of this square root. And this, what about third one? Yes, it does represent, there are two separate waves, they are traveling, they are superimposing. So here we can find the resultant amplitude. So they will be mutually perpendicular, that is 3 square plus 4 square under root, so that will be 5, and even we can find the angle between the two by using tan inverse. And then what about next one? Separately they will represent, but in a combination they will not. Right? So here superposition of the two waves will take place. Here also the same thing is happening. Now, next question is, a wire stretched between two rigid supports vibrates in its fundamental mode with a frequency of 45 Hz. The mass of the wire is this much and its linear mass density is 4 into 10 power minus 2 kg per meter. What is the speed of transverse wave in the string and the tension in the string? Question is simple. We can analyze it easily. So here, first of all, we have to find out what is length. So for that, what we can do? We know that mass per unit length, mu equal to mass divided by length, or suppose length we want to find out, length will be equal to mass divided by linear mass density. In our question, mass is given 3.5 into 10 to the power minus 2 divided by linear mass density is 4.0 into 10 to the power minus 2 kg per meter. So from where we can get the value of length, that is 0.875 meter, right? So this is first part. Now next point is we have to find out frequency. So frequency nu is given by 1 upon lambda, or just write 1 upon 2L, and root T upon mu, right? So we can put the values. Mu is already given, and tension in our question is the speed of transfer, the tension is to be found. So we can evaluate what is tension. So nu frequency is given in our question. This is 45 Hertz. So we can write here 45 equal to 1 upon twice of length. Length we have evaluated 0.875, and then root of tension divided by mu. Value of mu is given, that is 4.0 into 10 to the power minus 2, and we can square and simplify to get the value of T. So let's simplify it. So this will come out to be 248 Newton. So there is no problem. And now speed, suppose we want to find out. So for this, V equal to, we can write V in this case. So question says tension is speed of transverse wave. So speed, either you can evaluate directly by putting this, you have got the value of T, V equal to root T upon mu, just write, and you will get the answer, and that will be around 78.75 meter. 75 meter. You can evaluate. Now there is another question. A meter long tube open at one end with a movable piston at the other end shows resonance with a fixed frequency source, a tuning fork of frequency 340 Hz when the tube length is this much centimeter or this much centimeter. Estimate the speed of sound in air at the temperature of the experiment. The edge effect may be neglected. So in this question, we have to consider different points. So frequency of nth mode we write. So frequency of nth mode we can write nu n is equal to 2n minus 1 times v divided by 4l, right? Where n can have any value 0, 1, 2. It can't be 0, sorry, it will become negative. So it will be 1, 2, etc. Right? Now, here L1 and L2 are given. So we can find the value for suppose n becomes n1 for first value when this is 25.5, and n becomes say n2 when the value of L is 79.3. Then corresponding here resonance occurs. So if resonance occurs in this case, then the two frequencies will be same. So you can say twice of n1 minus 1 times V, right, divided by 4 times length. First length is 25.5 is equal to 2n2 minus 1 times V divided by 4 times this value 79.3, right? We can simplify to get the relation 2n1 minus 1 divided by 2n2 minus 1 is 1 upon 3. So it is possible if n1 equal to 1 and n2 equal to 2. Obviously, if we write here n1 equal to 1 and 2 equal to 2, then what do we get? This will become 1, this will become 3, correct? So we have got the relation. So now further we can check next step. So we have got nu n is equal to 2n minus 1 v divided by 4 L. And here, if we want to find out velocity, then what do? We just write nu n into 4L divided by 2n minus 1. And here we can put the values. N1 equal to, in our question some information is given here, speed is given here. We can take this length for this value. So we are taking L equal to 25.5 centimeter, and N we are taking as 1, and frequency we are taking as 340. We can put these values to get velocity. So nu, and that is 340 multiplied by 4 multiplied by 25.5 divided by, this will become 1, right? So this will come out to be 346. Is there something missing? This is in centimeter, keep in mind. So here what do? We divide it by 100, right? Because it is in centimeter, so answer will be meter per second, 346 meter per second, right? So this is answer. I think you have understood. So the remaining questions we will do in next lecture. Thank you for watching. Team Educate.